Something is breaking open beneath Hawaii and it's no longer staying contained. Deep below the ocean floor, Kilauea is forcing molten rock upward, with a level of pressure that is starting to overwhelm the system itself. Lava isn't just erupting, it's being driven skyward with explosive force, reaching heights that challenge the scale of anything built on the surface. But the real concern isn't how high it rises. It's the pattern. This isn't a single eruption. It's a repeating cycle, one that has continued again and again. Each time pushing harder, each time releasing more energy than the last. Pressure builds beneath the surface, the ground responds. And then it happens again, almost as if something below is refusing to settle. And now, new fractures are appearing. New offshore pathways forming where none existed before. That's not a system calming down, that's a system searching for new ways to release what it can no longer contain. Which raises a question that's becoming harder to ignore: what exactly is this building toward? Stay with Climate Update for continuous updates. Subscribe and turn on notifications so you don't miss what happens next. It's from the surface, it might look like a distant glow, a flicker of orange against dark volcanic rock. But closer in, the reality is far more intense. The floor of Kilauea's caldera is constantly shifting. Its layers of hardened lava are being buried, broken, and rebuilt again as new molten rock pushes upward from below. What was solid ground weeks ago is now cracked, uneven, and slowly being consumed by fresh flows. It's not a static landscape, it's a surface being rewritten in real time. And it doesn't begin with explosions. It starts quietly. Thin streams of lava creep outward, spreading across the caldera floor, almost slow enough to ignore. But underneath that movement, pressure is building. The surface begins to swell, heat intensifies. Then suddenly, the system releases and the calm gives way to violent upward force. This pattern keeps repeating. Subtle movement, rising tension, then rapid escalation. From above, it may seem controlled. But beneath the surface, everything points to a system under continuous stress, adjusting, shifting, and pushing towards something not fully revealed yet. Drop a 9 in the comments if you're interested in this topic. What's happening here isn't just intense, it's sustained. Kilauea has now pushed through a sequence of 42 eruptive episodes in just over a year. Not isolated bursts, not occasional activity. A continuous cycle that keeps returning, each time with measurable force behind it. And this pattern traces back to a turning point, when something beneath the volcano shifted and locked into motion. Since then, the system hasn't truly paused. Each episode releases massive volumes of molten rock, reshaping the caldera floor again and again, then resetting as pressure begins to build once more. What makes this different is consistency. Each cycle follows a familiar progression. Pressure accumulates below, minor overflows begin, then the system escalates into sustained lava fountaining. It repeats with a rhythm that feels almost mechanical, something rarely seen in a natural system this complex. But here's where it changes. The numbers aren't stabilizing, they're re-increasing. Each new episode is pushing harder than the last, higher fountains, greater volume, stronger release. What started as a repeating pattern is now beginning to resemble something else entirely. Not just a cycle, but a build-up. To understand why this keeps happening, you have to look beneath the surface into the system driving it. Each eruptive episode follows a sequence that now appears almost structured. First, pressure begins to accumulate deep within Kilauea's magma reservoir. Molten rock rises slowly, forcing its way upward through existing pathways. At the surface, this shows up as minor overflows, subtle, almost unremarkable. But that's only the beginning. As pressure continues to build, those pathways start to narrow under stress. Heat intensifies, the ground responds. Then comes the release, sustained lava fountaining that vents massive amounts of energy in a short period of time. And once it ends, it doesn't reset to zero. The system immediately begins reloading. Fresh magma moves upward to replace what was expelled, restoring pressure beneath the surface. The cycle restarts not after long dormancy, but almost continuously. That's what makes this different. This isn't a volcano calming down between eruptions. It's a system maintaining momentum, holding pressure, releasing it, and rebuilding again without fully stopping. It's the scale of what Kilauea is releasing is difficult to process until you translate it into something tangible. A peak intensity. The eruption rate reached roughly 780 cubic meters of molten rock every second. That means, in just a few seconds, enough lava is being produced to fill an Olympic-sized swimming pool. And this doesn't happen briefly, it continues for hours. Over the course of a single episode, more than 11 million cubic meters of molten material can be pushed to the surface. That volume does just disappear. It reshapes the landscape, deepens the lava lake, and rebuilds the caldera floor layer by layer. If you were to spread that amount of material across a large urban park, it would bury everything under dozens of feet of solidified rock. Trees, roads, open space completely covered. And this is not a one-time release. It has happened again and again across dozens of episodes, each one adding more material, more pressure, and more structural change to the system. When you look at these numbers together, it becomes clear, this isn't just activity, it's accumulation on a massive scale. At first, there were only slow overflows, thin sheets of lava spreading across the caldera floor. Almost steady, almost controlled. It looked familiar, predictable. But beneath that surface, pressure was already building faster than before. Then the shift happened. Within minutes, the first sustained fountains broke through. Heights climbed rapidly, pushing past hundreds of feet in a short span of time. And instead of stabilizing, the system accelerated. The fountains doubled, then surged again, each phase escalating with almost no delay in between. By peak intensity, molten rock was being forced upward with extraordinary energy, reaching heights that redefined the limits seen in earlier episodes. The eruption rate surged, releasing an immense volume of material in a continuous stream that held for hours. This wasn't just another cycle repeating. It was the same pattern but amplified. Every stage moved faster. Every output increased. And the system showed no sign of resisting the escalation. Instead, it seemed to adapt to it. It's as if the pathways beneath the surface had widened just enough to allow even more force through. And when it finally slowed, the pressure didn't disappear. It reset, already preparing for what comes next. For dozens of episodes, Kilauea followed a familiar layout: two primary vents, north and south, channeling most of the eruptive force to the surface. Scientists knew where to watch. They understood the boundaries. Then that changed. During the peak of the latest episode, new openings began to appear, not just minor activity, but sustained output from locations that had remained inactive throughout the entire cycle. A third vent, it's possibly even a fourth, briefly joined the eruption, pushing molten rock alongside the established channels. At first glance, it looked like an expansion. But the implications go deeper. One of these openings may have been a hornet or a false vent formed when pressurized lava breaks through the surface of an existing flow. Even so, it still signals internal pressure seeking release in places it normally would. The other possibility is more significant. A previously quiet intermediate vent may have reactivated after months of silence. If that's the case, then the structure beneath Kilauea is no longer behaving within the limits observed before. New pathways don't form without reason. They form when the system can no longer contain what's building underneath. As the fountains intensified, the eruption didn't just reshape the ground, it pushed far into the sky. A towering plume of gas, ash, and fragmented lava surged upward, reaching heights of around 35,000 feet, the same altitude where commercial aircraft operate. At that level, the material isn't contained near the volcano. It enters powerful wind streams capable of carrying debris across vast distances. Inside that plume, molten rock is shattered into fine particles: ash, volcanic glass, and solid fragments that eventually fall back to the surface. Where they land depends on one factor that cannot be controlled: wind direction. In this case, the fallout was carried toward a remote, unpopulated desert region. The impact was contained. No major structures were affected, but that outcome was not guaranteed. In a previous episode, similar material drifted toward populated zones, forcing evacuations and temporary closures in surrounding areas. The eruption strength may have been lower, but the impact was greater. That contrast reveals the real risk. It's not only the eruption itself, it's where the atmosphere decides to take it. What comes next is no longer a question of if, but when. It's based on the pattern established across more than 40 eruptive episodes. Scientists have outlined a projected window for the next phase. Episode 43 is expected to begin within a defined timeframe, built from the same cycle that has repeated again and again. At first glance, that level of predictability might seem reassuring, but it isn't. It's because what it actually confirms is that Kilauea is not behaving randomly. It's operating with a sustained system, one that builds pressure, releases it, and then rapidly resets. There is no long pause, no clear cooldown period. The process continues beneath the surface, even when the eruption above appears to end. And now, with new vents emerging and the structure showing signs of strain, the next episode may not follow the same pathways as before. That changes the equation. A predictable window does not mean a predictable outcome. It only means the system is still active and still building toward whatever comes next. What we're seeing at Kilauea is no longer a routine volcanic phase, it's a system that continues to intensify with each cycle. 42 eruptive episodes have already reshaped the landscape, pushed lava to extreme heights, and opened pathways that didn't exist before. The pattern hasn't slowed. It hasn't destabilized. It has evolved, becoming more forceful. It's more complex and more difficult to anticipate. And now the next phase is already forming beneath the surface. Magma is rising again, pressure is rebuilding. The structure is adjusting in ways that suggest the system is still searching for balance or pushing beyond it. Whether the next eruption follows the same vents or forces open new ones is a question that remains unanswered. But one thing is clear: this is not the end of the sequence. It's part of something ongoing, a cycle that continues to develop with every release of energy. And whatever comes next may not look like what we've already seen. Subscribe to Climate Update for accurate, real-time coverage you can trust. Turn on notifications so you never miss critical updates. Like and share to keep others informed. and stay connected as we track these changes together.